Welcome to this video on AutoSys Azure Logic Apps solution. In this video, we will explain the Azure Logic Apps integration with AutoSys and what it brings to the AutoSys user community. Azure Logic Apps is a cloud-based platform for creating and executing automated workflows without extensive coding knowledge. With its visual designer and library of pre-built operations, you can efficiently build workflows that seamlessly integrate and manage various applications, data, services, and systems. Integrating AutoSys with Azure Logic Apps allows you to trigger and run workflows created in Azure Logic Apps directly from AutoSys. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the design and execution sequence of an Azure Logic Apps trigger run workflow job. Finally, we'll run through a demo. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating Azure Logic Apps allows us to centrally configure process automation in AutoSys. Subsequently, we can run, trigger, and supervise all processes from a single interface. These Azure Logic Apps processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to effortlessly execute and monitor Azure Logic Apps jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Simply define your Azure Logic Apps jobs and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are clearly indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of Azure Logic Apps jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is fairly simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. All the target system properties, including the endpoint, run job REST API, client ID, client secret, scope, and other parameters are defined in the J2EE parameters. These parameters may vary depending on the authentication method used. Let's look at the sequence of execution. We start with the three main components: the AutoSys scheduler, the system agent, and the Azure Logic Apps server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job from the scheduler and initiates communication with the Azure Logic Apps server. Authentication is then initiated, with the system agent posting OAuth 2 authentication or access token authentication, depending on the specifications provided in the authentication J2EE properties. In this video, we are using OAuth 2 authentication using a proxy, which uses a combination of a client ID and a client secret. AutoSys allows connections via proxy, providing additional flexibility and security in accessing Azure Logic Apps resources. Once authenticated, the agent submits the job to the Azure Logic Apps server as a POST request. The Azure Logic Apps server identifies the matching job and executes it. The job execution returns a JSON response which contains the execution details. Both the Azure Logic Apps server and system agent then monitor the job until it reaches its final state. Once the final state is obtained from Azure Logic Apps, the job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer system agent install directory/path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses Azure Logic Apps public REST API. In our demo, we will create an Azure Logic Apps Pojo job in AutoSys. First, let's establish communication with the Azure Logic Apps server. After communication is established, we can execute and supervise the job. Let's dive into the world of applications and job execution within the Azure Logic Apps environment. In this demo, we're going to take a closer look at our Logic Apps instance. We've already prepared and executed the workflow for this demo. Let's navigate to the next step. This workflow is quite straightforward. It sends requests to various URLs. The code is designed to retrieve data using a basic GET request from a specific URL. Moving forward, we will now share the status code that we've received. Next, let's proceed to log in to AutoSys. Click the Quick View tab to view the job definition. Select the job to open the job definition. The job employs OAuth 2 authentication using a proxy for the demo. When the job is open, click the Quick Edit button to view the required parameter. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name, which is Azure Logic Apps, and the second is the method name, which is the Run Workflow job. Now look at the gateway parameters. Understanding these gateway parameters is an essential part of the process. The endpoint parameter indicates where the Azure Logic Apps service resides. The auth endpoint parameter specifies the URL where OAuth authentication takes place. This URL ensures secure access to Logic Apps resources by verifying user identities. Moving on to the client ID, it serves as a unique identifier that is used to generate a token for OAuth authentication. The client secret, on the other hand, is a confidential secret that is used in the process of generating a token for OAuth authentication. The scope parameter determines the level of access granted to the application for accessing Azure Logic Apps resources. The version parameter specifies the version of OAuth being used. You can choose the OAuth version that best meets your requirement. The workflow name parameter specifies the name of the workflow within Azure Logic Apps that you want to execute from AutoSys. The payload parameter specifies any additional JSON data that should be included with the request. If there is no additional data, this parameter can be left blank. Then we have proxy parameters. The proxy hostname specifies the hostname or IP address of the proxy server to which the connection is established. The proxy port indicates the port number the proxy server uses for communication. The proxy username is required for authentication with the proxy server. The proxy password is the password associated with the username for authenticating with the proxy server. The max retry parameter is crucial as it determines the maximum number of attempts the job status will be fetched from the Azure Logic Apps server for monitoring purposes. The sleep interval parameter specifies the duration of time the system agent should wait before querying the Azure Logic Apps API again to obtain the job status. In the event of a brief downtime experienced by the Azure Logic Apps service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. Lastly, the log level parameter allows you to specify the level of detail that should be included in the log file. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the Job and click Go. To confirm the job execution, click Yes when prompted. Notice that the current run number for the job is 5319. Upon refreshing, a new execution is triggered, increasing the run number from 5319 to 5320. A status of success indicates that the last execution was completed successfully. To access the spool files, simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. Now, let's take a quick look at the job status in the Azure Logic Apps instance. As you can see, this was the job that we triggered and it is completed. And that's a wrap for the demo on how AutoSys can integrate with Azure Logic Apps to execute and monitor various jobs. Thank you for watching this video.